Hi dear students, to my session for grade 9 elite. This is a much requested video from all my students and my subscribers. So here I am with the new video for your math revision. This is going to be really helpful video for all of you preparing for your coming exams. And in today's session we are going to be covering math end of term for the second term exam coverage for part 2. So stay glued with me and watch the video till the end so that you can benefit, and a gentle reminder to like, share and subscribe to the channel so that it serves as a motivation for me to make more and more videos for you. Covering part 2 of your end of term exam coverage, and these are going to be the next 10 multiple choice questions. So make sure you have watched part 1 of the video. I will put the link in the description box. After you finish watching part 1, you can come to this video on part 2 and see how we are going to solve the questions that you see in example 1 are from the topic of dilations. So we are going to use the concept of enlargement, reduction and scale factor to solve them. Let's start with question 1. The blue figure is the original figure which is on the left, and the figure on the right is the enlargement or reduction after you do the transformation. So from blue to the green, if you see, the size has become bigger. That means the size has enlarged. So this is a question on enlargement. This is a question from blue to green. It has size reduced. So it is a question on reduction. Next is also a question on reduction. And this one from blue to green, it has become bigger. So it is a question on enlargement. So therefore, because it is enlargement, you know the scale factor is going to be more than 1 for this and also for this question, whereas the scale factor is going to be less than 1 for reduction. So for these two questions, the scale factor will be less. Now, what is the formula for the scale factor? We need to find scale factor denoted by K is equal to the division of the size or the dimension of the new image divided by the old image. Or you can say you divide the length of the image divided, that is after the translation, by the pre-image, which is before the translation. So here 18 divided, 18 inches is the length of the side after enlargement and 6 was before. So 18 divided by 6 is going to be the scale factor, that is going to be 3, and yes, it is more than 1, so it's correct. Here the new size after reduction is 6, old was 12, so 6 divided by 12, that is new divided by old for the scale factor, so 1 by 2 or 0.5. Definitely it is less than 1 because it's a reduction. Next you have the scale factor for question 3 as 6 divided by 9, which is 2 by 3 less than 1, correct. Last but not the least, the new size is 8, the old was 5, so 8 divided by 5, that's your scale factor for the last one. So you can check your answers in this slide. So enlargement 3, reduction 1 by 2, reduction 2 by 3, and enlargement 8 by 5. So these are the answers. Next we move on to question 6, 7, 8 and 9, and in these questions we will use the concept of scale factor for finding the new coordinates. So let's solve it on this slide. The concept that I'm going to be using here is that the old coordinate needs to be multiplied by the scale factor to give you the new coordinate. So that is the rule. Multiply by k or the scale factor. So if the old coordinate is x comma y, the new coordinate will be k multiplied with x and k multiplied with y. Okay, so let's do it. I'm going to do answer 6 and 7 first. So let's solve it here. Let me write all the old coordinates j, k, l. These are the old coordinates, minus 8 comma 0, minus 4 comma 4. I'm writing it in x comma y format. And then you look at the scale factor. Scale factor is less than 1. That means the new coordinates would be reduced. So when you multiply it with 0.5, the new coordinate will be j prime, k prime, and l prime. So multiply with 0.5 is same as dividing by 2. So you divide 8 with 2. So minus 4 comma 0 is the new coordinate, minus 2 comma 2 and minus 1 comma 0. Okay, so what did I do? I will change color and write I multiplied with 0.5 or 1 by 2. So that's how you get these new coordinates. That's the answer for 6th. Let's do 7th here. Now, if you look at question number 7, one glance and you know that the scale factor is more than 1, so this is going to be an enlargement. I write the old coordinates first, STV, so S is 0, comma 0, T is minus 4, comma 0, V is minus 8, comma 8. Now, when I multiply it with K, that means I multiply with 1.25, S prime, T prime, and V prime. These are the new coordinates. So 0 multiply any number multiplied to 0 is 0 only. So this is not going to change. Similarly, this 0 is not going to change. Only 4 is going to be changed. So minus 4 will be multiplied with 1.25. Similarly, minus 8 will be multiplied with 1.25 and 8 will be multiplied with 1.25. So this is how you will get your answer. I will do one more part. There's less space, but I will do it. The method is going to be same. So let's do answer 8 here. So in this, you have three coordinates A, B, C. A is 9, 9. B is 3, 3, and this is 6, 0. Now look at the scale factor. It is 1 by 3 or less than 1. So this is a question on reduction. The new coordinates A prime, B prime, C prime after the dilation will be lesser than this. So when I multiply with 1 by 3, it is same as dividing by 3. So this is 9 divided by 3, 9 divided by 3, 3 divided by 3, and so on. 0 will remain unchanged. So the new coordinates that will come is A prime as 3, 3 after reduction, B prime as 1, 1, and C prime as 2, 0. So this is how you solve. Similarly, you can solve question number 9. Solve these questions on AA similarity. Most of them, question 1, 2, 3, 4, and 5 will be solved using AA similarity, and the last one, question 6, will be solved using triple S similarity. So let's recall what is AA similarity. When the angle of one triangle is equal to or congruent to the angle of the other triangle, that means it has the same measure or the same value, then we can apply a similarity and we can say two triangles are similar using AA criteria. So if I get any two triangles similar, any two angles similar of one triangle to the other, I am done with AA similarity. So we have to check here for these all triangles that you see whether they are similar or not and give reason for the same. So you see this marking for the first question, this and this are equal already, one pair is equal, and if you see they intersect at the point H, so these are vertical angles, so the other pair is also similar. So two angles are similar to the two others, so by AA similarity the two triangles are going to be similar to each other. Let's look at the other one. One angle is 98, another is 98. So one is already equal. This one is 42, but this one is 40. Both are not equal. So let's find the third angle. So this one, the third angle, angle R, will be equal to 180 degree because the sum of all three angles is 180 minus the other two angles. So 98 plus 42. So when you simplify, this comes out to be 40 degrees. So this angle is 40, and similarly this angle using angle sum is 42. So all the three are equal actually. So 98 equal to 98, 40 equal to 40, and 42 equal to 40. So again they are similar by AA similarity. Let's look at this one. This is again very similar to question number 1. If you see they are intersecting at the point C, so these are vertical angles, becomes equal, and this angle B is alternate angle to angle F. Why? Because AB and DF are parallel and they're intersected by the transversal. So again by AA similarity, these triangles are similar. Let's look at these right angles. One is 90, one is 60, so the other has to be 30 by angle sum property, and this has to be 60. So again, this is similar by AA similarity. Then we move on to question 5. In question 5, angle 41 is equal to angle 41, but this is 87 and this is 52, so we need to find the third angle and this angle here. So if you see carefully, this angle comes out to be, again we are using angle sum property, 180 minus 87 plus 41. So this is going to be 180 minus 128 degrees or 52 degrees. So if it is 52, this is equal to 52. So by AA similarity, this is again similar to each other. So all these questions till now we have solved using double A similarity. So they have come out to be similar. But this question, question 6, is different. Why? First of all, here the angles are not given. What are given are the side lengths. So you have to apply SSS similarity. You have to check whether this is holding true or not. That means you have to see that all the three pair of sides are proportional to each other or they are in the same ratio. If that is true, your triangles would be similar, otherwise not. So let's do the ratio. So 8, the corresponding side is 10, so the ratio will be 8 over 10. 9, the corresponding side is 12, so the ratio will be 9 over 12. 15, the corresponding side is 20, so the ratio will be 15 over 20. So what are these values? Let's see. 8 over 10 in simplest fraction is 4 over 5. 9 over 12 in simplest fraction is 3 by 4. And 15 by 20 is also 3 by 4. So two ratios are equal, but the third one is different. So can I apply SS similarity? No, these triangles are not similar because the sides are not in the same ratio. They are not proportional. Okay, so for question 1, 2, 3, 4, 5, and 6, we've already discussed the answers. So you can check your answers using the similarity. Now we are going to solve two very, very important word problems, question number 7 and 8. These are highly important and I really want you to understand the method to solve them. We are going to use a little bit of trigonometry, little bit of algebra and similarity in solving the questions. So I'm going to solve answer 7 here and answer 8 on the next slide. The answers, the final answers are shown to you here, and there is a figure given for question 8 which you can use while you solve, but there's no figure for question 7, so we are going to draw the figure. So pay attention how I'm drawing the figure. First, I'm making the cell phone tower, which is a pretty long tower. So it is going to be having, say, height h. That is what we need to find in the question. How tall is the cell phone tower? So I keep it as h. Then this is the floor, the ground. From a point, Leah is standing. So this girl is definitely smaller than the tower. So when I'm making the figure, I'm getting a right triangle. For example, this is Leah standing here in the middle and she's making an angle of theta. Theta is the angle that you don't know here. It is unknown, but what is given to you in the question is that the shadow of the cell phone tower is 100 feet. That means 100 feet long is the length of this tower. Okay, so this length is 100 feet. Okay, and then what else is given? Leah stands near the tower and casts a shadow 3 feet 4 inches. Now look carefully. This is a question which requires basic algebra. You have two units, feet and inches given. So you are going to convert them into one unit before you proceed. And the conversion factor that we are going to use is 1 foot is equal to 12 inches. So if I have to convert this 100 feet, how much it will be? So 100 feet in inches will be multiplied with 100. So that's going to be 1200 inches. So this length is same as 1200 inches. I'm converting all the units into one. So I'm going to convert this 3 feet 4 inches and 4 feet 6 inches also into inches. So let's do it. So 3 feet 4 inches we have to convert to inches. Now feet, 1 foot is 12 inches, so 3 feet will be 12 multiplied with 3, and there's already 4 inches, so I'm just going to add, and now the new unit will be inches throughout. So we have converted feet into inches using the conversion 1 foot is equal to 12 inches. Okay, I hope it is clear. So 1 foot is 12, so 3 foot is 12 multiplied by 3. So this simplification gives you 36 plus 4 inches, that's going to be 40 inches. So 3 feet 4 inches. This was actually Leah stands near the tower and casts a shadow. This is Leah's shadow. That means if you see the figure, this is Leah standing, this is her shadow, so this much length is going to be 40 inches. I've marked it in the figure. This is Leah. Okay, Leah is standing. And how much is Leah's height given to you? It's given 4 feet 5 inches. So I'm going to convert this also. So this is going to be 4 multiplied with 12 plus 5. Okay, so on simplification, oh, it's 6 inches, sorry. 6 inches, so you're going to add 6. So on simplification, this comes out to be 54 inches. And you can now mark this length is 54 inches. This height you don't know, you are given this much is 40 and the total is 120. Now we are going to use the concept of similarity of the triangles. So what I'm going to say, this angle is common in both and these are right angles. So these two triangles, which two triangles? I'm going to change color and show you. This smaller one, smaller right triangle, and the bigger one, let me use purple, this one. These two are similar to each other. So if they are similar, their sides are proportional. So you can use proportionality of sides for solving the question. So what I can say, this height and this side, which represents the height of the cell phone tower, and the height of Leah are proportional. H divided by 54, and it is proportional to what? It is proportional to the total length of the shadow, which is 1200 for the shadow of the cell phone tower, and what is Leah's shadow? It is 40. So they are going to be proportional. Now this relation we will solve by using cross multiplication to get the value of h. Now before I cross multiply, I can cancel the zeros, and now 4h is going to be 54 multiplied by 120. So here you can solve it, and your simplification gives you h is equal to 1620 inches. Now the final answer is given in feet, so we are again going to use this conversion, and this length which you got in inches, now you have to convert to feet. That means you are now going to divide by 12. So when you do that, this comes out to be 135 feet. So the answer is 135 feet for this question. What did we use? We used the conversion factor, 1 foot equal to 12 inches, and we also used similarity of the two triangles, the small and the big one. In a similar way, we are going to solve question 8 now in the next slide. Question 8. In this question, we are going to use a little bit of trigonometry. So if you see there's a right triangle given to you, I'm going to redraw it again for you just to make things more clear. So observe, this is the height of the light house. This is 48. This is the height of the person Maya. It is 6 feet, and the total length of the shadow of the tower is x. This much is y, and this much is 8. So the shadow of Maya is 8. So this is very similar to the last question. I'm going to draw another figure just to make things more easy and clear for you. So this is the right triangle. First of all, this is the person standard. How much? 6 feet is the height of the person. Then 48 is the height of the lighthouse. This much is y. This much is 8, and the total is x. So you can very well say x is equal to y plus 8, right? This is the equation, because when you add y and 8 together, you get x. Now what you need to find in the question, you need to find x and you need to find y. So first step would be to find x, and after that sorry, first step would be to find y, and after you get y, just add 8 to it and you are going to get x. So what I'm going to do here is I'm going to use trigonometry. Let this angle be theta, and because for this theta, if you remember SOHCAHTOA and a little bit of trigonometry, then tan theta is going to be the trigonometric ratio that is going to really help for this question. So what is the definition of tan? If you remember TOA, tan is opposite over adjacent. You divide the two and what you get is tan. So I'm going to calculate for the small triangle first the value of tan theta. So I'm going to write here tan theta is opposite. So opposite is 6 and adjacent. Adjacent is 8. So 6 divided by 8. That is the value of tan theta from the first and the small triangle. Now I'm going to change color and make the bigger triangle once more. So this is the bigger triangle, and for the bigger triangle I'm going to use the same trigonometric ratio tan theta. Let's calculate what it comes out to be. So for this big triangle, this angle is same, theta is same, the opposite changes to 48. And if you see the denominator, the adjacent is y plus 8, or you can write x also. I would prefer y plus 8. Okay, now both the values are equal to tan. You can see this left side and this left side is equal. So this right side and this right side is also going to be equal. So I will use here cross multiplication to simplify this expression. So let us cross multiply and simplify. So this gives you 6 times y plus 8 is going to be 8 multiplied with 48, or y plus 8 is going to be 8 multiplied with 48 divided by 6. When you simplify this and solve, it comes out to be 64. So from here I'm going to write here now y plus 8 is going to be 64, and actually from y plus 8 you can get the value of y 64 minus 8, and that is going to be 56. So have you got the value of y? So answer for B part is 56. Khalas, we are done with that. And x is nothing but y plus 8. So add 8 to this. So x is equal to y plus 8. So it is going to be 56 plus 8. That is going to be 64. So the value of A part is 64. That's how you solve the question. Very, very important. We are solving is very easy, just using the basic definition of geometric mean. So geometric mean of two numbers, for example a and b, is the square root of a multiplied with b. So I'm going to multiply the two numbers and take its square root. So the geometric mean of a number, the number that we don't know, let's say it is x, and 4 times the number. So 4 times is 4x, is given to be 22. What is the number? So you need to find the value of x here. So let's apply this concept. The first number a here is x, and the second number is 4 times x. So I'm going to multiply them both and take the positive square root. So x multiplied with 4x, that is going to be square root of 4x whole square. Now this number is given in the question as equal to 22. So I'm going to just equate it to 22 to get the value of x. So we are going to square both sides. Let's square. Why I'm squaring? Because I want the x to be out of the square root. So this is going to be 4x square equal to 22 multiplied with 22. So x square is 22 multiplied with 22 divided by 4. Simplify, and this comes out to be 211. I start dividing by 2, and then I divide this by 2 also, so 121. So if x square is 121, what we need is the value of x. So we are going to take the square root of 121, so that is 11. So the value of x is 11. The number is 11 here. The next set of questions that we are going to be solving are the following. In these questions, we have to use similarity criteria for triangles and also the concept of geometric means to solve problems. So let's see what are the answers and solve them one by one. So for the first one, question 18, we already have seen the answer is 11. For question number 19 and 20, you need to give the two column proof. So it has been provided here. You can go through it and write the steps. For question 21 and 22, we are going to use the concept of geometric mean. The answer is again provided here for you. You can see the sample answer as well, and I will give you the formula or the concept. Let me recall it for you, the one that you are going to use for solving question 21. So if you have a right angle triangle like the one that you see here, I'm going to draw one more figure here just to make things more easy and clear for you. So assume this is a right triangle, this angle is 90, and from the right angle you're dropping a perpendicular of height h. This side is b, this side is a. This one is x, this one is y, and when you add x and y, what you get is c. This is the other side. So this is capital C, this is capital B, the vertex, this is capital A. So it's a right angle triangle. So the formula that we are using for geometric means using similarity of criterion is that this edge is going to be the geometric mean of x and y. So this edge is going to be geometric mean of x and y. First, I'm just giving you the formula, then we can apply it for this question. Then this length A is going to be the geometric mean of y, the shorter leg, multiplied with c. Similarly, b is going to be the geometric mean of x multiplied with c. So this is the formula sheet. This is coming from the lesson on geometric means. We have done the altitude theorem and the leg theorem. So this is very, very important. Now, for this question, if you see, h is replaced by y. So the formula becomes, when I apply, y is equal to the square root of x multiplied with y. So x is x here and y is 8.8. So this is how the formula is applied. Similarly for A, that is any leg you take, for example, I take this leg first. So the formula application will be 8.5 is equal to, which is the leg close to it, x multiplied with the total length. So it is x plus 8.8. This is the next equation. And the last equation is B, which is the value of z here. So z is going to be equal to the length which is close to it, that is 8.8 multiplied with 8.8 plus x. So when you solve these three equations, what you get is the final answer: x equal to 5.2, y equal to 6.8, and z equal to 11.1. So that's your answer. Let's do question 22. For 22, there's a sample answer provided. You just have to compare and contrast. Compare means what are the similarities, what are the differences between arithmetic and geometric mean of two numbers. So I would like you to recall here that arithmetic mean of two numbers a and b is given by the formula a plus b, add them, divide by 2. Whereas geometric mean of a and b, you already know, is the formula square root AP. So you just have to compare them. Now the question says, when will these two means be equal? Justify your reasoning. So now let me explain this to you. Both the arithmetic and geometric mean calculate a value between the two numbers a and b. That's quite sure that that's coming from the formula itself. Now the two means will be equal when a and b, when both the two numbers are equal. And how you can check that? By making them equal. So put this equation a plus b by 2, that's the arithmetic mean, equal to the geometric mean square root of this, and simplify. And when you simplify by applying basic algebra, expanding a plus b whole square, taking the terms to one side, you will get the step that a is equal to b. So when these two means will be equal, when the two numbers are also equal. That's how you justify your answer. Let's solve question 23, 24 and 25 now. For question 23, you need to find two pairs of whole numbers with a geometric mean that is also a whole number. And also you need to check what condition must be met in order for a pair of numbers to produce a whole number geometric mean. So there can be more than one correct answer for this. As a sample answer, we are taking the numbers 9 and 4 and 8 and 8. If you see these numbers, both of them result in geometric mean, which is whole number. So for two whole numbers to result in whole number, the geometric mean, their product must be a perfect square. That is the condition. So if you see 9 and 4, what is the geometric mean? 9 multiplied with 4 in square root. That means square root of 36, and this is 36, a perfect square equal to 6. So when does this come as a whole number? When it is a perfect square. That's the condition. Similarly, you can check for number 8 and 8. 8 multiplied by 8 is 64, which is again a perfect square of 8. So that is a sample answer. Okay. Next is you find the error. There are two people, Aiden and Tia, and they're finding the value of x in the triangle. Aiden does this work, it is shown here. Tia does this work, it is shown here. You have to check which of them have done the correct explanation and explain your answer. Now, if you look carefully, Aiden has taken this side divided by this side is equal to this side divided by 6. He has taken all the sides of the small triangle, which is not at all true. So definitely Aiden is wrong. In such a question, you have to apply the geometric mean theorem, which I explained to you a few minutes ago in the previous slide when we did question number 21. So Aiden has wrongly applied the theorem. Let's look at Tia. Tia does 3.6 divided by x is equal to x divided by 8. Again, Tia has also done wrong. She has also not taken the proper triangles, and she has also not applied the theorem of geometric mean, the altitude and the leg theorem incorrectly. So neither of them is correct. The correct answer would have been if they would have used the geometric mean theorem and geometric leg theorem correctly. So both are wrong. Question number 25. Here you need to analyze. You have to just say A, B, C. Three statements are given to you. Which one of them is sometimes true, which one of them is always true, and which one of them is never true. Also give reasons. So first of all, the A part, that is the geometric mean for consecutive positive integers, is the mean of the two numbers. That means it is saying that geometric mean and arithmetic mean is always equal. This is not at all true. It is going to be different unless and until the two numbers are same. So this is never true. B part, the geometric mean of two perfect squares is a positive integer. That is going to be always true. Why? Because when you are taking the geometric mean, the formula is geometric mean of two numbers a and b is the square root of a and b, and when you are taking out of the square root, you're always taking out the positive number. So as long as your two numbers a and b are positive, the square root is also going to be giving you positive results. So the geometric mean for two positive squares will always be the product of two positive integers, which is going to give you a positive integer as the geometric mean. So b is always true. Let's look at C. The geometric mean for two positive integer is another integer. This is sometimes true. The case would be different when either of the number is a negative number. In that case, the result would not be a positive number. So this is sometimes true. And the sample answer is when the product of two integers is a perfect square, the geometric mean will be a positive integer. Let's solve these problems using the special triangles. So there are two types of special triangles I would like to revise for you. 30, 60, 90 triangle and 45, 45, 90 right triangle. So we are going to solve these questions without using calculator but using the special right triangles. As you see, that's what we have to see in the learning objective. And then you can round off to the nearest 100, that means two decimal places, if you get a decimal as your answer. So first let me recall for you for the two special triangles. The first special triangle is 30, 16, 90. Okay, so one angle is 30. I'm going to draw the figure also. This is the 91, definitely. This is 30. This one is the bigger one, 60. Now, in this triangle, H is your hypotenuse. X is the smaller leg that is opposite to the smaller angle. So look here carefully, 30 is the smaller angle, so X is going to be the smaller side. 60 is the larger angle, so opposite to it will be Y, which is the longer leg. Okay, so this is the first kind of triangle. And in this triangle, the formula that we are going to use is that hypotenuse, or this one H, is going to be 2 times the shorter leg. So 2 times the shorter leg is x, so 2x, and y will be square root times the shorter leg. So this is the formula sheet, very, very important. We are going to use this for solving questions of the 30, 60, 90. That means question 5, question 8, question 9, and question 7 we are going to solve using this triangle. Why I've selected only these 4? Because you see angle is 30, 60, 30, 60. So 30, 60, 90, this formula is going to be valid. So let's solve this question first. So I'm calculating sine of 30 degrees. Sine of 30 means this angle I'm taking, so opposite over hypotenuse. SOHCAHTOA. Let me write it on the top so that you don't forget. SOHCAHTOA. We are using trigonometry. So sine is opposite over hypotenuse. So what is the opposite one to 30 degree? It is x over hypotenuse, which is h. Now h is equal to 2x by the formula. So x divided by 2x is sine 30 degrees. So x and x khalas. What is left? 1 by 2. So in fraction, sine 30 is 1 by 2, and in decimal it is 0.5. So that is the answer for the question number 5. Okay, let's do the remaining questions also. So now I'm going to do sine 60 for you. So sine 60, again I'm going to use the formula, so opposite over hypotenuse, but this time I'm taking this angle. So opposite would be y over hypotenuse will not change, that is x. So y is how much? Root 3x by the formula, and x and x khalas. So root 3 sine 60 is the value. Oh, I forgot to put the value of h also. H is how much? 2x. So x and x khalas, so this is root 3 by 2. And if you convert it into decimal, this is going to be 0.87. So this is the answer for question 8. In a similar way, now let's go to 60 degree angle. So we are going to do cos of 60 degree. Now cos is adjacent over hypotenuse. So that means adjacent is the side which is near to it. So if I take 60 degree, the near to it is x. So x divided by hypotenuse. Hypotenuse is 2x. So I'm going to put the value x divided by 2x. X and x khalas. So this is 1 by 2 or 0.5. So that's cos 60 for you, question 7. Last one is tan 30 degree. So tan is TOA, means opposite over adjacent. So I go to 30 degrees, opposite is x, adjacent is y. So this is x over y. Now y value from the formula for the special triangle is root 3x. So x and x again cancels. So tan 30 degree is 1 by 3. We can rationalize it to remove the radical sign. So this is root 3 over 3, and you can convert it into decimal. This is going to be 0.58. So this is how you solve the questions using special triangles and a little bit of trigonometry. Okay, let's do the remaining questions. The solutions are provided here for you. So we are going to now solve tan 45 and cos 45 using the other special triangle, which is 45, 45, 90. So this is very, very simple right triangle. You first draw it roughly. This angle is 90 and this angle is 45, equal to the other angle 45. So if these two are equal, this is going to be x, this is also going to be x, and this is your hypotenuse. So the formula that is valid in this triangle is h equal to square root 2x. So we are going to now use this formula for tan 45. So tan is TOA, which is opposite over adjacent. So opposite, take any angle, both are equal to 45. The opposite is x, and the adjacent is also x. So x divided by x is going to give you 1. So tan 45 is 1. Similarly, let's solve for cos 45. Cos 45, SOHCAHTOA again. So cos is adjacent over hypotenuse. So for 45, the adjacent is x and the hypotenuse is h. Now your hypotenuse has the formula root 2x. So I'm going to put that value, cancel the x. So 1 by square root of 2. Now we are going to rationalize this. That means we are going to get rid of the radical in the denominator. So this is going to be square root 2 over 2, or if you convert it into decimals, 0.71. So this is how, using special triangles, you can solve the questions without using a calculator, but the basic knowledge of special triangles and trigonometry. So that is all for the session for today. There is some part of part 2 still left, but it was becoming a very long video, which will be difficult to upload. So I'm going to put another video for part 2 in a few days. That is going to be in continuation with the part 2 that has come in the end of term coverage. So don't worry, you will get that part also. Till then, you watch this video till the end. Don't forget to like, share and subscribe. Also press the bell icon to receive notification of my new video that I will upload, and also for part 3. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.